We live in an age in which technology is becoming even more complex day by day. But the increasing of this complex generates new challenges because each electronic device generates electromagnetic field, and all these electromagnetic field put together can create interference to other devices. So the question is, how the devices react to this interference? The answer is given from immunity test. My name is Francesco Pio Cecca and I'm a PhD candidate at Otto from Guericke University, and I will now take you into the world of electromagnetic compatibility. We talked about immunity testing, but how can we do an immunity test? One way is to put our device inside a reverberation chamber. What is a reverberation chamber? A reverberation chamber, you can imagine like a huge microwave with the goal of cooking our device. Now, for a energy efficient cooking, we want that the walls of our chamber needs to be highly reflective. And for a uniform cooking, we want to use a rotating stirrer inside the chamber. It's just like a microwave oven, with the difference that there is the food that is rotating, and in our case is the stirrer that is rotating with the goal of change the reflection angles of the input signal. We have to decide now which kind of signal we have to use as an input electromagnetic field. One of the most common that we can find in the nature are that kind of signal that contains a large amount of energy in a really short time. And this kind of signal are called pulsed excitation. My research is focused on the study of the behavior of the pulse excitation in a reverberation chamber during immunity test, and how the generated interference interact with the devices under test. So far, models with a steady state result were developed. What this means? This means that we know the result some microseconds after the switching on of the signal. But with pulsed excitation, this is a problem, because in pulsed excitation, it was discovered that in the transient part, so in the exact moment in which the signal is switched on, we have a higher value of electric field. And the problem is that with the model that study only the steady state, we don't know the value in the transient part, but at the same time, the immunity test fails, and we don't know the reason. This topic generated also the attention of European Union that through NEPIT project is financing my work. Actually, I'm working on the development of a model that can predict the mean and the maximum value of the electric field and the peaks inside the reverberation chamber in order to make safe and reliable immunity test possible.